on page 63, problem 23, they give you a dihybrid cross. And part of the way you know it's a dihybrid cross is that you're looking at some different traits here. You can see that it's round yellow, round green, wrinkled yellow, wrinkled green. These are both dominant and these are both recessive. This is one dominant trait, this is one recessive trait, this is a recessive, and this is a dominant. You look at your pattern and you say to yourself, maybe this does fit the classic dihybrid cross. In fact, that's what they're asking you to check to see if this fits the 9:3 to 3:1 expected ratio. And when you look at that, when you add 9 plus 3 plus 3 plus 1, that adds up to a total of 16 possible. So you make it a fraction of 9 out of 16. That's your expected ratio. The next thing you want to do is plug in your observed. And the way you know to plug in the observed, the 9/16 should match with the one that has two dominant traits. Round and yellow, those are both the dominant ones. That goes in this box. These two can go in either order because they both have one dominant and one recessive. So this is the round green, plugs in there, and the wrinkled yellow plugs in there. And the one with both recessives has to be the 1/16, and you plug it in there. So then to figure out what your expected should be, you add up all of the offspring. You get 556. You multiply each of these fractions times 556. So 9/16 times 556 is 312.75. 316 times 556 is 104.25, which is this one correct as well. And 1/16 times 556 is 34.75. Now to determine your deviation, it's observed minus expected each time. So 315 minus 312.75 gives you 2.25. 108 minus 104.25 gives me 3.75. 101 minus 104.25 gives me a negative 3.75. 32 minus 34.75 gives me a negative 2.75. To get my deviation squared, I simply square each of these deviations. Then to determine my chi-square value, it's the d squared divided by, deviation squared divided by the expected. So this would be 5.0625 divided by 312.75, giving me a 0.016. And this is a 14.0625 divided by the expected of 104.25 to give me 0.135. And I take my 14.0625 again divided by my expected of 104.25. That's the same there. Here I take 7.5625 divided it by my expected 34.25 and I get a 0.217. My chi-square value is the total of all of these added together. And when you add those together, you end up getting 0.5. To determine your degrees of freedom, that's the number of categories. In this case, it's 4 minus 1, because there's 4 possible phenotypes. Minus 1 gives me a degrees of freedom of 3. I then go and find on the degrees of freedom the 3 row, and I'm looking for the number along the chi-square value on this 3 row that's closest to 0.5. In this case, there's a 0.58. Then I look up, and that gives me a probability of about 0.9. That means that it falls in this darker blue area, which we say fails to reject the null hypothesis. And in other words, that means yes, these differences, these deviations can be explained by chance, and this 9 to 3, this does fit the 9 to 3 to 3 to 1 ratio.